important for MBA finance students. First of all, we'll discuss the problem and then we'll solve. That means this is a problem relating to capital budgeting. Okay, what is the problem? See, this is the problem. The problem is a company named ABC and Company is considering purchasing of a new automatic machine to replace an old one. The main purpose for installing this machine is to reduce labor cost and increase production capacity in order to meet the growing demand for its product. Because of this, the company expects higher profits for the next 3 years. Okay. The future demand for the product is uncertain. So, annual cash flows cannot be predicted with certainty. Instead, the company has estimated possible cash flows along with their probabilities for each of the next 3 years. Possible cash flows are given year-wise with probability. This is the data for first year. Cash inflows, all these are the cash inflows. 10,000, the probability is 0.3. 15,000, the probability is 0.4 in this way. You can check the sum total of the probability is 1. For the second year, the probability for the cash flows are noted here. 10,000 probability is 0.1 in this way. 40,000 cash inflows, the probability is this. It is estimated data. Third year, because the project is for 3 years, for third year, the cash flows with probability is noted here. 10,000 with probability 0.3 in this way. The cost of the new machine is rupees 70,000 and the company can sell the old machine for a scrap value of rupees 28,000. The discount rate is 15%. Now, what you have to calculate? Requirements. First, evaluate the investment proposal. Should we accept the investment proposal? By calculating the net present value based on the expected cash flows. This is the first requirement. Second, analyze the risk associated with the project using simulation method. And finally, third, use the following random numbers to simulate 5 possible scenarios of cash flows. Actually, in practice, there is a random number table and also it is available in Excel sheet or in computer. But here, for exam purpose, the 5 sets of random number is given for each year. You have to use these random numbers only, then it will be clear that you know how to use the random numbers to solve a simulation problem. Okay, for exam purpose, the random number will be provided in this way. Based on the simulation, calculate NPV for each simulation test and determine the expected average NPV and find the probability that the NPV of the project will be less than 0. All these are requirements for the project. Okay. Now, I have already discussed the problem. Again, I am repeating the problem background. That is, ABC and companies considering installation of a new automatic machine. The purpose for installation or purchase of the new machine is reduction of labor cost, increase in production capacity, and meet growing market demand. The machine is expected to generate cash inflows for 3 years. Okay. Now, problem situation. Future demand for the product is uncertain. That is not deterministic. Therefore, annual cash inflows cannot be predicted with certainty. I think it is clear. As the demand is uncertain, that's why cash flow cannot be predicted with certainty. Instead, different possible cash flows with probabilities are estimated. But cash flows with probabilities is given here. Simulation technique will be used to analyze the risk. Okay, this is the problem background. Now, here again I am summarizing the given data. This is the possible cash flows for first year. This is the cash flows, means cash inflows with probability. That I have already shown in the given problem. That's why I am not going to discuss. This is for second year cash inflows, 10,000 with probability 0.1, 20,000 for probability 0.2 in this way. And for third year, probability and cash flows are given. 10,000 cash flows, the probability is 0.3, 20,000 cash flows will be with the probability 0.5 and 30,000 cash flows with the probability 0.2. Okay. Now the investment details. Cost of the new machine. What is the cost? Rupees 70,000. and the scrap value of the old machine is 28,000. Then actually what is the initial investment? Because this is the inflow of fund, inflow of cash you can say, and this is the outflow of cash. You have to pay 70,000 to purchase or acquire the machine, and you will get scrap value 20,000. That's why net initial investment will be this minus this 42,000. Discount rate is given 15,000 and project life is 3 years. These are the investment details. Okay. Now random numbers for simulation. It is given first year. The random number, 5 sets of numbers are given, 4, 7, 6, 5. This is the 5 numbers, 1, 2, 3, 4, 5. For each year, the random numbers are given. How we have to use that I will discuss when we will solve the problem. Okay. Now steps for solving the problem by simulation. This is the steps for using the simulation technique. First, convert probabilities into cumulative probabilities. Assign random numbers interval and use random numbers to generate simulated cash flows. Okay, and calculate NPV for each simulation set and find average or expected NPV in this way. So this is the steps. You can again check it. Now I am going to show the detailed calculation through Excel sheet. This is the Excel sheets for the problem. The solution part is shown in this Excel sheet. The problem year-wise cash flows I have already mentioned, given here in this Excel sheet. First year, second year, third year. This is the cash inflows, the probability, cash inflows, the probability in this way. Okay, and initial investment 70,000 and the scrap value 28,000, and these are the random numbers. 5 set of random numbers are given for each year, 1, 2, and 3. And the discount rate is 15%. First, expected cash flows at present value. Okay, first year 10,000 with probability 0.3. That's why expected value is this into this, that is 3,000. The probability for 15,000 cash inflow is 0.4. That's why expected value is this 6,000 in this way. That is total expected value after 1 year, first year is 15,000. The discount rate is 15%. That's why the present value factor is 0.870. This is the formula I have used, 1 by 1 plus R, that is the discount rate, and the value will be 0.870. You can check it. This is the present value factor after 1 year. And if you multiply the expected cash flows with this factor, then you will get the present value of the cash flows after 1 year. This is the present value for the cash inflows for after 1 year. Okay. Similarly, after second year, the cash flows and the probabilities are given, and this is the expected cash flows 10,000 into probability, that's why 1,000 expected value after second year. In this way, after second year, the probability for 20,000 cash inflows is 20%, 0.2. That's why the expected value will be this into this, that is 4,000. In this way, all the cash expected value are calculated here, and the total amount received after 2 years, after second year, is 29,000. 15% is the discount rate. The present value factor for 15%, as it is after 2 years, that's the present value factor would be 0.56, and the formula has been used here. You can see the power is 2 as it is after second year, and if you multiply this with this, then you will get the present value whatever the cash inflows is being received after second year. The total expected cash inflows at present value will be this. In this way, after third year, all the cash flows are this with probability. Similarly, as we have done, the expected cash flows are calculated, and the total cash inflows after third year, after 3 years, will be this 10, 16, 19,000, and the discount factor, present value factor for 15% is 0.658. You can see the formula here. The power is 3, as after 3 year you are receiving this amount, third year. That's why the present value factor will be this. If you multiply this, then this is the present value of the expected cash flows or inflows after third year. Okay, then what is the total value of the cash inflows? Present value. Present value will be, you have to add after first year you are receiving this 30,043 plus this 21,928, and this is for third year. That is the total expected value of the cash inflows is this. for this project. And what is the initial outflow, cash outflow? That is 42,000, that we have already calculated initially. 42,000. How 42,000? 70,000 minus 28,000. 28,000 is the scrap value. That's why this is the 70,000 minus 28,000. This is the net cash outflow at the present value. And the difference is this: as the NPV, net present value, is positive, that's why the project can be accepted. The project is viable to be accepted as NPV greater than 0. This value is greater than 0. Okay. Now we are going to discuss simulation analysis, the application of simulation technique with the help of random numbers. How you will deal it, that I am going to discuss first. Year wise, first what you will do, you will calculate the cumulative probability. This is the probability for 10,000, 0.3. For 15,000 cash flows, the probability is this. In this, what is the cumulative probabilities? Cumulative probabilities. This is the cumulative probabilities. Okay, this is cumulative probabilities. Cumulative probabilities. Okay, that is 0.3. Point accumulation means you have to add 0.3 plus 0.4, that is 0.7, and 0.7 plus 0.3, 1.00. 0.3 means 10,000 cash flows, the chances is 0.3. That's why out of 10 cases you will take the 3 cases. Here single column is taken, that's why the option is 0 to 9. That means 3 cases. 30% means 3 cases. 0.3 means 30%. The out of 10 cases, 3 cases you have to allocate for 10,000. That's why 0, 1 and 2. This is the process by which you have allocated. And for 15,000, 40% means 4 cases. 4 cases you have to allocate the random number. Okay, appearance. So 4 cases means up to 2 you have taken here, 3, 4, 5, 6, 4 cases. Out of 10 cases, 4 cases for 15,000 in this way. For 20,000, the case will be 30%, that means 3 cases. So up to 9 single column random number is given here, that is possible number is 0 to 9, that is the total 10 cases. So after this, the 3 cases, 7, 8, 9. In this way, the random numbers are allocated here. For second year cases, these are the probabilities. First you have to prepare the cumulative probabilities. This is actually cumulative probabilities. Okay, and this is 0.1 cumulative probabilities. Actually you have to, it is to be increases cumulative probabilities. Okay, 0.1, 0.3, 0.1 first is plus 0.2, that's why 0.3, and you had 0.4, that is 0.7, 0.3 plus 0.4, and 0.7 plus 0.3 is 1.00. 10%, 0.1 means 10%. Or from 0 to 9, 10 cases are there, 10% is only 1 case, that's why 0 is given here. And 20% means 2 cases. So after that 1 and 2. And 40% means 4 cases. 4 cases, that's why 3, 4, 5, 6 up to 2, after 2. And 30% means 3 cases, 7, 8, 9. In this way, for third year also, the random numbers are allocated with the cumulative probabilities. Okay. Now next, we are going to calculate the present value for all the sets of random numbers. Okay, for all the sets. Which are the sets? 1, 2, 3, 4, 5 sets are given, and 3 years, year 1, year 2, year 3. For year 1, the random numbers is given 5 sets, 4, 7, 6, 5, 0. You can see 4, 7, 4, 4, 7, 5 for first year, 4, 7, 6, 5, 0. 4, 7, 6, 5, 0. You can check it. 4, 7, 4, 7, 6, 5, 0. These are the random number given. On the basis of this, the value of cash flows you have to take. First, for the first year, if the random number is 4, then what will be the cash flows? You can see for the first year, allocation of random numbers first year, 4. 4, where is the 4? Here is the 4. Then cash flows will be 15,000. That's why you see the cash flows has been taken 15,000. Now next random number is 7. Then what will be the cash flows? 7. You see for the first year, where is the 7? 7 is this. There's a 20,000 will be the cash flows. See, the 20,000 is the cash flow. In this way, all the cash flows are noted here on the basis of random number provided in the problem. 5 sets of random number, 5 trials we are giving here. As in the exam, it is not possible to take the long list or huge number for calculation. Actually, it is better and practical if you use the computer. Okay, but here is no provision for that. That's why we are discussing to 5 sets of number only. 5 times randomly we are taking the values. Okay, so in this way I am showing randomly one more. To suppose this case, in this case second year the random number is 8, then what value of cash flows you will take? You see, for second year, go to this table, the 8, where is 8? This is 8. That means the cash flows you will take 40,000. If the random number is 2, then you have to take the cash flows 20,000 in this way. Here it is 8, that's a 40,000. We are taking the case of 8, that is 40,000. So in this way all the cash flows are noted. For third year also I am showing anyone. Suppose this one, the random number is 3 for third year table. See what will be the cash flows. Go to the third table, third year 3. Where is the 3? That's a 20,000. 20,000. Let us see. If this random number is taken 0, then what will be the cash flows for third year table? You go and check. Third year table, where is the 0? This is the 0. That means 10,000. 10,000 will be the cash flows. 10,000 is the cash flows. In this way, you prepare the table considering the random number and its relating cash flows. Now, after 1 year, the discounting factor or present value factor, as the discount factor is 15% is this. This is the figure after 1 year, and all 5 sets have been tried. Then what will the present value? These are the present, this into this. This is the present value. If the random number is this, then the present value, expected present value is this. In this way, 5 sets of present value have been calculated. For second year also, this is the cash flows and this is the present value factor. Why this is different? This is after 1 year, and all these figures are after second year. If the after second year means the present value factor will be this. You can check the formula is power square 1 plus 0.15 to the power 2. That's why all the discount factor, present value factor after second year is this. And if you multiply, then you will get the present value. And after third year, this is the random number, cash flows, and the present value factor is this. Present value after this value is being received after third year. That's why the present value, you have to multiply the present value factor for 3 years. Let's see, this is the power. I have used the formula. You can check the formula. And if you multiply this, then you will get the present value. In this way, the present value, all the present values for different sets or random number have been calculated. Then for first set, what is the expected present value? This is the expected present value. How it has come? You can check the formula. This is the formula. F18 is this plus this plus this, and if you add this, then you will get this. In this way, for 5 sets of trials, you will get the present value which are calculated here. Through Excel sheet, it is very easy, because once you have done, just you can drag it, then you will get the value of the computation. Now the last stage we are discussing here. For first set, the expected present value is this, and what is the cash outflow? That is 42,000. Why 42,000? That we have already discussed. 70,000 is the outflow of fund for purchasing the machine, and 28,000 is the scrap value which is being received by the company. That's why the outflow is 42,000. So this is the present inflow, present value of inflow, cash flows, and the outflow. What is the NPV? This minus this, that is negative. That's why it is written as negative. For this case, second set, you can check it. This is the, for the second, 59,801. 59,801, but the cash outflow is 42,000. And what is the NPV? If you subtract this, then 17,800. This is positive. For third year, this is the 56,440, and this is the outflow. Is the net present value is positive 14,440, and this is fourth set. Again, it is negative in this way. And what is the average NPV? Average NPV, if you make total of this and divide it by the numbers, then you will see this is the average NPV. But if you check, then how many trials you have given here? 5 trials, out of which how many negative NPV is 1, 2, 3. That means the project will be rejected out of 5 cases, 3 cases. Out of 5 situations, for 3 situations the project will be rejected. That means the 60% probability or 60% chances that the project will be rejected, that the NPV of the project may be turned out to be negative. We know that if the NPV is negative, then the project will be rejected. And the acceptance, only 2 cases the project will be accepted out of 5. That means what is the probability? That is out of 5, 4 means 40% cases. Another we can also calculate 1 minus 0.6 is 0.4. That's why 40% cases the project will be accepted. In this case the risk is tremendous high because the 60% chances the project should be rejected. Okay, so by 5 times simulation we have solved this problem and come to this conclusion. To make it unbiased and practical, you have to make the trial 1000 times and even more that, and which is possible only through computer. Thank you. Thank you. Oh, sorry. Sorry. This is the calculation part only. Now we have to summarize also. Financial analysis, the summarize the result. After calculating NPV for all simulation sets, compute the expected NPV and determine the probability that NPV less than 0. This helps management to understand the risks associated with the investment decision. Okay, and this is the final conclusion of this problem. Simulation is a useful technique when future cash flows are uncertain. It helps to estimate possible outcomes and measure project risk. Managers can make better capital budgeting decisions using this approach. Okay, thank you, and if you like it, please put like and also share to your friends and others and subscribe. Thank you.